Hello everyone, I've got my Ryobi TSS121 compound miter saw here. I installed a Softstart on it. When I first was using it, it kicked fairly significantly when starting it up. I felt it was probably better for the motor and safer for me to put something that brings it down a little bit. I had one other start module on there first, and then I wasn't working out quite the way I expected. I did some research, found out this has an electric brake on it, and I think I figured out how to wire this in so the electric brake isn't impacted anymore. So this is the Hitachi model. These are push lock pins, so there's nothing exposed. I just have the heat shrink on here to hold everything together until I get it more permanently mounted. This is kind of a temporary configuration while I get it, make sure it works out well for a little bit. I have one little slot I had to cut into the side here. There we go. So that you can feed the cables through, and then of course a couple holes to mount the module tool. You can see the extra hole there from the previous module. But go ahead and give it a quick startup, and anybody who has this motor knows the kick it's got to it. And there's the eBrake. But you saw how much slower it kicked on than it normally would. It took maybe about a second to come up to full speed, maybe a little bit less. The other module was taking about 3 seconds and sounded absolutely horrible. I'll go over the wiring and everything next. I have some drawings I put together since I couldn't really find anything detailed online. And then some pictures I took of the wiring inside the handle here. You do have to remove these two screws. This one has a captive nut on the inside that you have to remember to put back in place. You got a couple screws here and here you have to remove, and a couple underneath the handle as well. And the handle and this whole module comes up. The switch, this piece can come out separately. There are 2 wires leading up to this switch for the shadow line LED. So you just have to be careful when you pull this up before you disconnect those. And as always, make sure if you do this, make sure you're comfortable working around electricity and electronics, and that it's unplugged when you're working on it like that. I also have some pictures I took off the case off on the end of this. I didn't get the motor out, but I did see the terminations were in there and kind of put together a splice diagram of the stator. Really couldn't figure out how it's wired. I know the basics enough to be able to work this into it, but if anybody who wants more detail on that or knows more detail on that, please feel free to comment and let me know, and we'll go over the drawings in just a moment. All right, as y'all saw a moment ago, the e-brake took a moment to kick in. I tried it a couple more times. It was consistently inconsistent, and I think I figured out why, and I'll be showing that in a moment. But first, I'm going to go over the circuit as it is now. There is another Ryobi model TSS120L, I think, that has a wiring harness diagram showing the harness and the brushes. The biggest difference between it and this that I found was the shadow line module for mine was actually a laser module, and of course the LED was a laser. Everything else looked like it was the same. Those drawings do not show the stator coils, so I kind of had to poke and prod on the machine. When I took the motor end bell cover off, I saw that there were 5 splices in there. You can see the white wire where it terminated in, the brown wire where it terminated in, and the yellow going to the rear brush where it terminated in. There is also the standard copper wiring for the coils, and then there is this thinner copper wiring, and it's spliced over there. Hold on. It splices on this Charlie termination. So going through what I saw there, basic knowledge, I'm not an engineer. Hold on, that's a different YouTube channel. I don't have an engineering background, but I do have electrical background and electrical theory, and I've dealt with motors a bit. So I was able to get some readings. I couldn't measure in the Charlie splice, but I was able to get between the other terminations, and the readings I got kind of lined up with what I ended up seeing once I put together these splice terminations. And I'm fairly confident this is how the circuit's laid out. So the way this works, this is a momentary switch, means you have to hold it into the opposite position. This is unheld, so the mains power is open, and this other circuit that should be the eBrake is closed when you're not using it. You press the switch, it closes the top contact, opens the bottom contact, allows mains power only to the armature through the brushes, through the commutator, comes around, feeds through the stator coils up and returns to your neutral, giving you a complete circuit and allowing the machine to work. When you release this switch, it opens up the mains power, closes this other circuit, and as you can see, it feeds in through the armature as well, then goes through these coils here, and you end up with a rotating field because the armature is still spinning, going through a conductor capable of carrying a current. So you get generator action, and that acts as dynamic braking, magnetically coupling and slowing and stopping the machine, which is how you get it to stop faster. With that, this is the original wiring of the machine. These two conductors here go up to the shadow line LED on-off switch. You'll see that in a moment. Come over, this is your module just for that LED. Black and red wire goes down into the LED itself. Over here, you've got your terminal connector for mains power. You've got your white and black wire coming in. White wire coming out and going down into the machine. A black wire coming off and going over to the switch. Then you have a brown wire here going down into the machine to the stator coils coming to the switch as well. That's the eBrake. The outputs of the switch splice together and then come around, feed back down into the machine for your first brush, the one that's on this side here. And then we'll go down to the next page. Oh, it worked. Fantastic. There's the switch with those two conductors tied into it. It's a little difficult to pull them off, but not impossible. And it's easier to do that than to flex those too much, potentially break them. Here's the main switch. The little safety is off of it right now. It just goes into that slot. You can see 18 amp, 250 volt rating. This is similar to, but not the same as the schematic I drew up. It shows the switch open between those two contacts and close between these two contacts. You press it down, it'll close those and open this one. So this was my first attempt. Ignore the Hitachi label over there. The first time I did it was a different type of module. Whether was it because of the module or the way I had it wired in, it took about 3 seconds for the machine to come up to speed, and it sounded horrendous the entire time. It sounded like it was throwing itself apart. So I backed up and researched and found out about the Hitachi module. But when I got that soft start module, I spliced it in by the instructions between the main switch coming into it and going out to the machine, and then it also had a neutral wire going over. So it kind of acts as a bucket or a bladder. As it fills up, it slowly fills up over to here, and once it's full, it's providing full power out to your stator coils. As I did the research on the Hitachi module, this is the actual Hitachi itself. It is meant for their saw, so it's kind of a retrofit to this. As a gentleman whose YouTube, his video I'll put up here somewhere, that showed how to wire this into a machine that did not have an e-brake. The e-brake added a level of complexity to this that I'm trying to work around. The A, B, and C over here refers to the wires. We'll see that on the next screen. They are brown, black, and blue. And here you go, flipped over, brown, black, and blue. Good heat sink on the machine, on this module, and some sort of adjustment rheostat or potentiometer. I would assume that adjusts the amount of time it works to speed it up or slow it down. But I don't, the machine, but I don't know for certain. If anybody does know, please share in the comments. Myself and others could find that very helpful. So this is the configuration I'm in now with the Hitachi module. The mains power comes in the brown, feeds over, goes to the soft start, pulls it up, goes over to the black wire, then splices in to feed the circuit through the stator coils. It has a blue wire going over to the neutral connection. So what I think is happening, the reason that eBrake's taking so long to stop the machine, is this is acting like a bladder. You fill it up as the machine speeds up, and then it's full while the machine's running. You open this connection and you close this one when you release the switch. Well, this still has potential in it, so it's still feeding into the circuit to push the machine forward. You have to wait for this to bleed down enough for the e-brake to actually kick in. Um, Between a soft start and an e-brake, I would prefer the soft start considering how much the machine kicked. Uh, the e-brake, well, I've got the plastic shield on there that provides protection from the blade and the way it drops down, so I'm less concerned with that. But I am going to pursue one of the two options that I'm about to discuss. The first one, and the least likely, is finding a new switch in the same form factor and fit that has an additional contact that can put in that will open up this circuit when this is released. Just another one of these opens. So it'll close to make the circuit open when the mains is not available. So it just leaves the e-brake in its little circuit. I don't think I'm going to find a switch that fits that form factor. The other option that I actually am going to pursue is to put a uh, relay in. And I'm thinking I'm going to connect the coil between these two splices so that when I close this, it'll energize the coil, which will close a normally open contact to allow a flow path for this. And when I release the switch, the coil de-energizes, it'll open that contact and allow just the e-brake to be in the circuit. Well, we'll see how that works out. I know relays can be finicky sometimes depending on how you put them in the circuit. And I don't think putting it in series will work because of how this draws off power and would need to draw off power to close the contact. So I think it is going to have to be across there if it works at all. So this is the current configuration. You also at the beginning of the video. Uh, I got a little slot here I cut into the machine housing. I did file off the edges so that it's a softer fit, and my final configuration, I'll put a grommet or something in there, or potentially some heat shrink around the wires to give them a little extra protection. You can see I got the push to lock connectors. One of them has to be 3, so I just grabbed 3 of them. I couldn't find my ones that just did 2 conductors for the other 2 terminations. The original wiring, as you remember, the outputs were spliced here and it was a single conductor going here. With 2 conductors, you've got to watch out for some pinch points when you're closing the handle lid. I also left the original wiring to the motor at their original length so that if I have to go back to the way it was, I have a conductor to work with. Once again, once I figure out a configuration that works well for me in the long run, I will probably cut some of these back so that it's a less congested, and you'll see from a top-down view in a moment how that's laid out. When you're putting this back together, the most difficult part I found was putting this lid back on and not pinching any of these conductors, especially the ones to the shadow line switch. Also, I mentioned earlier on that there was a captive nut back in here. You have to be careful to put that back in or thread it in a bit before you put the housing down. And here is more of a top-down view. So you've got the brown wire and the yellow wire going down into the machine housing. You've also got this one white wire. This splice I added in because this terminal connector couldn't handle 2 14-gauge wires and the thinner gauge wire for the laser module. You can see I had to correct for the that one and that one not fitting in all the way. What I will probably end up doing is replacing the white wire and black wire there with something a little bit longer and terminating them in the back side of this connection where there's just the power cables coming in. It's electrically the same. And again, here's the switch, and you can see how there's cable management slots in the machine handle that don't really work out well for the way I'm doing this. And you can see how congested it is back here as well. And just a close up, there's the penetration that goes down into the actual, to this motor stator itself. And there's your yellow wire, brown wire, and the white wire over there that feed down into there. So, pending future changes, this is how it is configured. I think this will work with most machines that have this style of dynamic e-brake. There are other types of brakes, some with DC injection, some with actual mechanical brakes. So if it's a motor brake other than this type, it may not work out. You'd have to figure out some other means of setting this up. But if you find this useful, or you think someone else will find it useful, let me know. Please share, uh, provide feedback, and if you know a better way of doing it, let us know as well. Thank you much, and have a great day. Thank you.